Capstone project. Building a complete multi-container application. This project combines everything learned throughout the course. We will design a realistic multi-container application. Multiple services will work together as a complete system. The project reflects real-world Docker usage. Lesson objectives. Design a multi-container architecture. Understand service separation. Use Docker Compose effectively. Implement networking and volumes. Apply production best practices. Course concepts applied. This project uses Docker images, containers, Docker files, networks, volumes, Docker Compose, security practices, monitoring concepts. Project overview. Application components. Front-end service. Back-end API service. Database service. Each component runs in its own container. System architecture. Users. Front-end. Back-end API. Database. A common architecture used in modern applications. Why multi-container applications? Benefits. Separation of responsibilities. Independent scaling. Easier maintenance. Better security. Improved reliability. Application components. Front-end service. User interface. Static content. API communication. Back-end service. Business logic. Data processing. Database service. Data storage. Persistence. Front-end container. Responsibilities. Serve web pages. Display user interface. Communicate with backend. Examples. React. Angular. Vue. Jinx. Backend container. Responsibilities. Process requests. Validate data. Communicate with database. Examples. Node.js. Python. Java. .NET. Database container. Responsibilities. Store data. Retrieve data. Manage persistence. Examples. MySQL. PostgreSQL. MongoDB. Container networking. Front-end. Back-end. Database. Services communicate through Docker networks. Service discovery. Benefits. No hard-coded IP addresses. Easy communication. Flexible deployments. Service names act as host names. Data persistence. Containers are temporary. Volumes store data. Benefits. Data survival. Backups. Safer upgrades. Environment variables. Examples. DB_host equals database. DB_user equals app user. App_env equals production. Environment variables improve flexibility. Why use Docker Compose? Compose provides simpler management. Centralized configuration. Reproducible deployments. Ideal for multi-container applications. Compose architecture. Services. Front-end. Back-end. Database. Volumes. DB_data. Networks. App_network. Startup workflow. Docker Compose up. Create network. Create volume. Start database. Start backend. Start frontend. Application communication flow. User request. Frontend. Backend API. Database. Response returned. Scaling the backend. Backend X1. Backend X5. Backend X10. Additional containers handle increased traffic. Health checks. Verify. Availability. Responsiveness. Readiness. Healthy services continue receiving traffic. Logging strategy. Collect logs from front-end, back-end, database. Logs help identify and resolve issues. Security considerations. Best practices. Official images. Non-root users. Protected secrets. Limited port exposure. Backup strategy. Database volume. Regular backup. Recovery capability. Backups protect critical data. Monitoring strategy. Monitor. CPU usage. Memory usage. Response times. Error rates. Monitoring improves reliability. Deployment workflow. Developer updates code. Build image. Push image. Deploy containers. Verify health. Example project structure. Project / frontend / backend / database / Docker compose.yml .env readme.md. Production expansion. Additional components may include Redis, message queues, reverse proxies, monitoring systems, load balancers. Common challenges. Configuration errors. Network problems. Missing environment variables. Database connectivity issues. Troubleshooting skills remain important. Applying course knowledge. This project combines images, containers, Docker files, networks, volumes, compose, security, monitoring, production concepts. Why this project matters. Students gain experience with realistic architectures, service communication, persistent storage, deployment workflows. Portfolio value. Demonstrates Docker knowledge, deployment skills, multi-container design, practical experience. Projects help showcase technical abilities. Capstone architecture review. Front-end, back-end, database. Built using Docker Compose. Networks, volumes, environment variables. Benefits of the architecture. Modular design. Easier scaling. Better reliability. Simpler maintenance. Improved flexibility. Interview question. Question. Why are multi-container applications preferred over placing all services in a single container? Answer. Multi-container architectures provide better scalability, maintainability, security, fault isolation, and flexibility by allowing each service to operate independently. Key takeaways and lesson summary. Modern applications use multiple services. Containers isolate responsibilities. Docker Compose simplifies management. Volumes provide persistent storage. Networks enable service communication. This capstone project demonstrates real-world Docker practices.